Welcome to EDU World Space.
Problem 3.79. In this problem, three couples are given and that are acting on this system. We have to calculate equivalent couple and magnitude of the equivalent couple and their corresponding directions with x-axis, y-axis and z-axis. So first of all, we will try to find out the individual moment couple with its vector sign. So for vector calculation, we need two things: one, magnitude, and direction. Magnitude of each couple is already mentioned in the problem, but direction is not directly given. So we have to calculate directions. So first of all, let's say that the couple due to this 50 Newton force is M1. So we can get the couple value by resolving these forces into its components in the plane of A, B, C, D. So they will form two component of forces, one alongside AB and here the one along CD. So force couple will be formed here because of the force component along the side AB and CD, and the another component of this 50 Newton force will be along the side BD, and here at point C it will along side AC. So these two components again going to form a couple. So this one couple M1 can be calculated by adding these two individual couples. So M1 can be calculated by considering the anti-clockwise direction to be positive. So we need to find first the component along the line AB and along the line BD. Let's say component of this 50 Newton along the line AB is P and component along line BD is Q. Alright, so P can be written as, so P will be 50 cos theta, and cos theta can be calculated from this triangle. So if we observe this triangle, so this is triangle, this point is F, this point is A and this point is B. This length is 160, this length is 120. So this length will be under root of 120 square plus 160 square, which comes out to be 200. So 50 cos theta will be 50 multiplied by cos theta 160 divided by 200, and this comes out to be 40 Newton. Similarly, we can solve the value of Q, and this will be 50 sin theta, and that will be 50 multiplied by its sin theta value will be 120 divided by 200, and this comes out to be 30 Newton. So now here will also be a component along the line CD, and it will be also of same magnitude P, and this will be also of same magnitude Q, because these are the parallel lines. So angle made by the horizontal will be same. So here will be theta, here also theta. So P here will be 50 cos theta. Now this P has a separation of 240 mm. We can see here this is 120 mm. So total separation between these two anti-parallel forces P is 240 mm. So calculate. So the moment because of P component will be, and it is causing a counterclockwise couple. So this will be plus 40 multiplied by 0.24. So this will have the unit of Newton meter, and we are here calculating the magnitude of moment and considering the anti-clockwise direction to be positive. Now moment because of the Q component will be, since it is in clockwise direction, so it will be negative minus, and Q component is 30 multiplied by 0.16. By solving these terms, it comes out to be 4.80 Newton meter. Now magnitude of M1 we have got this here, but still we need to find the direction that in which the M1 will be. Since these two forces, that is PQ, or we can say that these two 50 Newton forces are in the plane ABCD. So their couple will act perpendicular to the plane ABCD. So we need to find the unit vector perpendicular to the plane ABCD. So for that, what we will do, that we will draw its side view of this wedge. So from side view, it will be a triangle. So this triangle, and it will be this point will be B, this is E, this is D, this length is 144 mm, this length is 192 mm, and this will be the perpendicular to the plane ABCD. So we have to find unit vector along this. So let's say this angle is theta. So this will be 90 minus theta. This angle is 90. Entire angle should be 180. So this angle will be theta. Alright, theta can be calculated from this triangle, and that is tan theta is equals to 144 divided by 192. So theta comes out to be 36.87 degree. Alright. Now if we have calculated theta, so if we consider this to be 1 unit, so 1 has a component, this was our y-axis and this was z-axis. So we can write the unit vector perpendicular to this, perpendicular to the plane ABCD, and that will be, if we write it in the form of unit vectors along y-axis and z-axis, so it will be cos theta j cap plus sin theta k cap. So we can write the M1 vector as magnitude. We have already calculated 4.8 multiplied by the unit vector that we have calculated here, that is cos theta j cap plus sin theta k cap. Now theta we have already found here, so we can put this value of theta. So it comes out to be 3.84 j cap plus 2.88 k cap. So we have got the value of M1. Now let's say that moment vector, because of these two forces, is M2, because they are of same magnitude and opposite in direction, and one can observe this, that they will cause a clockwise couple if viewed from the top of the plane XZ. So their couple will be in negative y direction. So we can write the moment M2 to be force, that is 12.5 multiplied by their perpendicular distance, that is 0.192 Newton meter, and its direction will be minus j cap. So if we solve these values, this comes out to be minus 2.4 j cap. So this is equals to minus 2.4 j cap. We have found these two values. Now we have to find the value of we have calculated the moments due to these two 50 Newton forces, these two 12.5 Newton forces. Now the remaining forces are 10 Newton. So to calculate the moment because of them, we can do one thing, that we can calculate the moment about point C. So if we calculate moment about point C, so because of this 10 Newton force, moment will be 0, because this force is passing through the point C. So the only moment will be because of this 10 Newton force. And for the calculation of moment, we need to know the position vector of point B with respect to point C and the direction of force vector. So we have to calculate position vector of B. So we need RB with respect to C. And this can be calculated as coordinate of C and B is known. Coordinate of C is, since it is in YZ plane, so X coordinate is going to be 0. Its Y coordinate will be also 0 since it is along Z axis. So it will have the z coordinate as 0.192. Obviously, we are writing it in meter. Now talking about the coordinate of point B. So coordinate of point B will be its x component will be 0.16, y component will be 0.144, and its z component will be 0 since it is in xy plane. So position vector of B with respect to C can be calculated by using these two coordinates, and it comes out to be r of B with respect to C is equals to 0.16 I cap 0.16 I cap plus 0.144 j cap and minus 0.192 k cap. So this is the position vector of B with respect to C. Now to calculate moment about point C, we can use this result here. So let's say we are going to find the value m3. So this will be position vector of point B with respect to C cross multiplied by the force that is acting there, and that is 10, and that is acting in 10 Newton downward. So this is minus 10 j cap. So we can put the value of r vector, that is 0.16 I cap plus 0.144 j cap minus 0.192 k cap cross multiplied with minus 10 j cap. Now we can solve I cap cross j cap. So I cross, first of all, if we write the magnitude here, so it will be plus minus 1.6 I cross j will be plus k cap, and 144 j cap, and here also j cap. So j cap cross j cap will be 0, and minus into minus will be plus 1.92 k cross j, and k cross j will be minus I cap. So m3 vector comes out to be minus 1.6 k cap and minus 1.92 I cap. Now m1 vector is known, m2 vector is known, m3 vector is known. So equivalent moment can be calculated by using vector sum. So m vector equivalent moment will be m1 plus m2 plus m3, which comes out to be m1 we have already calculated 3.84 j cap plus 2.88 k cap, plus m2 vector is minus 2.4 j cap, and m3 vector is minus 1.6 k cap minus 1.92 I cap. Now collecting the coefficients of I cap, j cap and k cap, it comes out to be, our final moment comes out to be minus 1.92 Newton meter I cap plus 1.44 Newton meter j cap plus 1.28 Newton meter k cap. So this is the final or equivalent moment that is acting on this system. Now to find the magnitude of this moment vector, we can square and add the individual components. So magnitude of m vector will be under root of minus 1.92 whole square plus 1.44 whole square plus 1.28 whole square, and it comes out to be 2.72 Newton meter. Now for the calculation of theta, so theta x can be calculated by using cos inverse its x component, that is coefficient of I cap, that is minus 1.92 divided by its magnitude, that is 2.72, and this gives the value of 134.9 degree. For the calculation of angle made by y, that is theta y, cos inverse we can use the coefficient of j cap, that is 1.44 divided by 2.72, and it gives the value to be 58 degree. Now talking about the theta z, that will be cos inverse the z component 1.28 divided by 2.72, and this comes out to be 61.9 degree.